Okay, let's look at 4.4 practice problems. Now, this first problem talks about a student places a sample of pure metal in a crucible and heats it strongly in air. Data from this experiment are given in the table above. This is the mass of the empty crucible. This is the mass of the crucible and sample before heating. And this is the mass of crucible and sample after heating. The final mass was determined to be after the sample was cooled to room temperature. And then it says that the following statements is correct. Which of the following statements is correct? Well, it says the mass of the sample decreased. They didn't. The mass of the sample increased. Right, so it's not this off the bat. The mass of the sample increased, yes. So a chemical change occurred when the bonds formed between metal and another. So that's what it looks like it happened. There was nothing for the metal to react with. Obviously not. Some type of reaction happened. Some type of chemical change happened. So this is not it. When the sample was heated, a chemical change definitely occurred, which is why it gained mass. So B is the correct answer. Yeah, as if the mass increases, something in the air must have joined the metal. It must have probably reacted with oxygen. A student mixes 20 grams of white potassium chloride crystals with distilled water in a beaker. After the mixture was stirred, no crystals are visible and the solution is clear. After several days, all of the water evaporates and white crystals are found in the beaker. Which of the following pieces of experimental evidence would best help the student to confirm that a new compound has not been made and only a physical change occurred? Okay, so where it's only a physical change if whatever they did, the solute came back. So they mix white crystals with water, and after everything, after it was stirred, no crystals were available, but eventually the white crystals reappear. So the solution does not change color after stirring. Obviously, it does change color because it says it started out with white crystals, and after it was stirred, there were no crystals visible, so it did change color, so it's not A. The crystals are no longer visible after mixing with water. Just because they're quote unquote disappearing, it just means that they dissolved. It doesn't mean that they are gone. So I wouldn't say it's B either. That's not proof that only a physical change occurred. Then there is a temperature change in the solution during the dissolving process. Temperature changes can happen during dissolving without a reaction. After the water had evaporated, the white crystals in the beaker have a this is the right answer, because this shows that there was only a physical change, not a chemical change, which is why we get exactly what we started with right back. Okay, next question. Okay. This table above summarizes data given to a student to evaluate the type of change that took place when substance X was mixed with water. The student claimed that the data did not provide enough evidence to determine whether a chemical or physical change took place, and additional tests were needed. Which of the following identifies the best way to gather evidence to support the type of change that occurred when water and X were mixed? So let's say water. Okay, it says summarize the student evaluate the type of change that took place when X was mixed with water. The student claimed the data did not provide enough evidence to determine whether a chemical or physical change took place, that additional tests were needed. And they want to know if what was the best way to gather evidence to see what type of it? So here we have the appearance of this, and then when you combine the two, it's still clear and colorless. So this kind of dissolves inside. Okay, so a phase change would be a physical change, right? Because in a phase change, a physical change, you don't break any covalent bonds. And so let's see, measuring the melting point. So measuring the melting point, it's not because a melting point of the mixture doesn't tell you if it's a pure substance, right? And we need to know which identifies the best way to gather evidence to support the type of change, right? And as far as we know, you want evidence that something new formed. That would be the clearest sign that a chemical change happened, right? If you're looking for evidence of a new substance, you would want like some type of precipitate or some type of residue, something that's left over that would help you understand, right? Add other substances to the mixture of water and ecstasy. Where there are solid forms, yes, a solid forms is precipitate. So this is what we're looking for, a precipitate. Another way of saying precipitate, right? And this is what we want. If there's a precipitate that forms, then that tells us that there was a chemical change, right? So I'm just going to circle B, because measuring and comparing the masses doesn't tell you anything. Measuring, because masses will always add up, and because of the conservation of mass theory, even if there is a chemical reaction. And then measuring the electrical conductivities of X in the mixture, what does that have to do with any physical or chemical change? That could happen in either case, and that doesn't mean any type of change happened. Okay, last question. Which of the following describes the changes of forces and forces of attraction that occur as H2O changes from... Oh, well, this is kind of straightforward, right? As something goes from H2O liquid to H2O gas, we have to think about like because it does that, it's still H2O. It's still good old H2O. None of these bonds get broken, right? None of that happens, and it just means that they're not as close. Because remember, I've showed you guys a million times, like solid ice is like they're packed together, right? The molecules. And then like with liquid, they're just like a little bit more further apart. And then with like gas, they're like really far apart, right? And that's the only difference. So let's see. HO bonds break. Hell no, that's not what happens. It's still H2O, so it's definitely not A. Hydrogen bonds between H2O molecules are broken. Yes, the only hydrogen bonds that would break are the ones that are like this. You know what I'm saying? These bonds might break. This might break. So maybe covalent bonds between molecules. There's no covalent bonds between molecules. There's just these hydrogen bonds. So this doesn't even exist. Ionic bonds. That doesn't make sense. Water is not ionic. There's no positive and negative end. There's not one is a metal and one is a non-metal. These are both non-metals. So these are both non-metals. So this can't be ionic. This is a non-metal. This is a non-metal. That can't be it. So covalent bonds between hydrogen ions and have become... No, this doesn't even make sense. How can they become more effective? So these hydrogen bonds that happen between water molecules that are close to each other, this right here, these will break. And that's kind of happening all the time, anyways.